Okay, this video is going to walk you through example 1. And at various times, you're going to be asked to finish part of it yourself and then enter it into Edpuzzle. So you definitely want to have the volume on, and you definitely want to be recording the notes on your paper as well. So we are on the polynomial foldable, and we are on the flap that says solving algebraically, and we're on example 1. Okay, so the steps are going to be incredibly similar to this, except there's going to be a little bit of an added wrinkle. So we spoke before about when you see this in standard form, we can look at our highest exponent and we can know how many solutions there are going to be. So in this case, there are going to be 4 solutions. There are going to be 4 solutions. Okay, now I'm not given any of those yet, and I cannot get them just by looking at this. And I'm not given a factor. So what we need to do is graph it. So just like before, we're going to graph it. And you're going to name the root. All right, so here we go. I did that into Desmos, so I've graphed it. And if I just go to my home screen here, you see that only x-intercept I can actually see is a 6. But there is something special about it, hopefully that you notice, and that is that it's a double root. So x equals 6, and it is a double root. Now that's going to come in handy, and we're going to need to know that because it's a double root, there's actually 6 and then another 6. So that's going to come in handy. So the next step we're going to do is to divide. So just like last time we divided. So same steps so far. So let's go over here and have you write this down. We're going to graph it. You're going to name the root. That's what we did. We got a 6, and this is actually a double root. So it's actually 6 2 times. So our next step is going to be to divide. And just like before, I'm going to take this problem and I'm going to divide it by what this root would be as a factor. So if you want to, you could write this as a factor. This is x minus 6. All right, so I'm going to do box method. I'm going to need 4 vertical lines because I have a degree of 4. Now, if you don't want to do box method and you do a different method, this is one of those times that synthetic would come in handy because it will be a little bit faster. But I am going to do box method. So here we go. I'm going to write my x minus 6, and then I'm going to write my dividend over here. And then I can actually do my division. Okay, so when I do my division, again, remember we want to have that remainder of 0. And we're really most interested in the quotient that we're going to get. So I'm going to put my 3x to the 4th here. 3 times x cubed gives me 3x to the 4th. And then I'm going to multiply my row and my column. And then I'm going to subtract. Negative 40 minus negative 18. I get negative 22 x cubed. And now I start the process over again. Negative 22 x squared times x gives me negative 22x cubed. Then I'm going to multiply my row and my column. And when I do that, I get 132x squared. And then I'm going to subtract 164 minus 132. And I get 32x squared. And what do I multiply x by to get 32x squared? 32x. And then I multiply my row and my column. and I get negative 192x. And then I'm going to subtract those. I get negative 48x. And I multiply x by negative 48 to get negative 48x, and then I multiply my row and my column. I know it didn't really look like this was going to work out, but it did. I have a remainder of 0. Now, here is the part where it's going to be different. And this is why we have a separate example. If you notice, this is not a quadratic. How do I know that? Because the highest degree here is a 3. This is actually a cubic. I cannot use quadratic formula on this. People will try, and they will do it incorrectly, and they will mess up the problem. You cannot use quadratic formula. What you have to do is you have to divide again. And you might be saying, but wait a minute, I only found one root. But aha, you didn't, because this was actually a double root. We can use that again. So I'm going to end up dividing again. I'm going to do it over here. This time I only have 3 vertical lines. I'm still going to use the same factor. But this time, and I want to be really clear about where this is coming from, my quotient right here is now going to become my dividend. So I have 3x cubed minus 22x squared plus 32x minus 48. So again, I want to be clear where that came from. We're still using the quotient, but I cannot jump to quadratic formula because I don't have a quadratic. Quadratic formula only works with quadratic, which is the highest exponent of 2. So I'm going to divide again. And the reason I can do that is because of my double root. So here we go, dividing again. I'm going to start with that 3x cubed here. So I'm going to multiply this by 3x squared to get 3x cubed. Multiply my row and my column. Okay, then I am going to subtract. Negative 22 minus negative 18 gives me a negative 4x squared. To get negative 4x squared, I multiply x by negative 4x. And then I'm going to multiply my row and my column again. So negative 4x times negative 6, I get 24x. And then I'm going to subtract. So 32 minus my 24, I'm going to get 8x. And then what do I multiply x by to get 8x? 8. And then I can multiply my row and my column. And lo and behold, again, it worked out. I have that remainder of 0. Remember, you have to have a remainder of 0. If you're getting something that's not a remainder of 0, you probably made an error somewhere in the problem. So you should go back and check that. Okay, now we actually have a quadratic. We have 3x squared minus 4x plus 8. That is our quadratic. So now we can actually do quadratic formula. All right, so I'm going to come up here so I have some space. So now we're going to use quadratic formula. Okay, and it is on the back of your bookmark. So you can get your bookmark out or use quadratic formula. All right. So my A, remember that's coming from my quotient down here. My A is 3. My B is negative 4. And my C is 8. All right, so I've got my A, my B, and my C, and I'm going to put that into the formula. All right. So I've got the opposite of negative 4 plus minus square root negative 4 squared minus 4 times my A times my C. All of that is over 2 times 3. Okay. All right, so I've substituted A, B, and C into the formula, and then I can simplify it. So the opposite of negative 4 is positive 4. got that plus minus. All of this is over 6. And when I put this in the calculator, and remember, we're just putting in the stuff under the radical. When I put that into the calculator, I think I get negative 80. I should get negative 80. Let's hope I get negative 80. Okay, so I can't stop there because I have something under the radical that has a negative, and it also might have a perfect square in it. So I need to break out as much as possible. All right, so this 4 is still here, and the 6 is still here. I'm going to take out that negative 1 first, because I know that can come out. That's going to become an I. And then I need to find the highest perfect square that goes into 80. So I'm going to take out my perfect square bookmark and my calculator, and I'm probably going to start around 49, maybe 36. So I divide 80 by 36, I get a decimal. I divide 80 by 25, I get a decimal. I divide 80 by 16, and that works. So that is my greatest perfect square, and the leftover is 5. Now, you could do that on your calculator so that you can actually check it. Now, if I had started down here, I might have stopped at 4, and then that wouldn't have been the largest perfect square, and I would have had to simplify again. All right, so here's my x. Now I can simplify all of this. The square root of negative 1 will become I. The square root of 16 is 4. It's not 8, and it's not 16. I've seen those as common errors, and the square root of 5 cannot come out, so that's stuck. So we're almost done, except if you notice all of these numbers are divisible by 2. So my final step, my answer is 2. I still have the symbols, and then 2i, radical 5, and all of that is over 3. So that was a lot of work. In fact, this is a B-level problem. There's a lot of understanding going on. That's the double root, there's the double division, and then we have quadratic formula. So my roots I have are actually 6 and 6, because remember it's a double root. And then I've got 2 plus minus 2i radical 5, and all of that is over 3. And just a reminder, this is actually 2 separate roots. So we do have all 4, and that's how you do a B-level problem.